Okay, in this lesson we're going to graph our trig graphs. So first of all, let's talk about the sine curve. If you recall in our lessons before, we've said the sine value is the same as y, okay? So here I'm starting with an angle of 0 and my sine value, the y, is also 0. So I've plotted 0 along the angle axis and 0 high, y, which is going to represent sine. Let's start to increase our angle. So now, as you can see, as my angle gets bigger, so now I'm at 21 degrees, my height, y, which is sine, is at 0.358. I'll keep going and you'll see the sine value, which is represented by that red line, the y, for each angle starts to get higher and higher until it hits 90 degrees and it's at 1 high. Now we're going to start to go into the second quadrant. So we've plotted from 0 to 90 all the different heights of y, which are values of sine theta. Now we're going to go into 180. So let's have a look what happens. It starts to come back down again. Okay, exactly the same fraction until when we hit 180, hopefully I can hit it, we're back down to 0 high. Now we'll go into the third quadrant and we know y starts to become negative, sine starts to become negative here. And we go all the way around to 270 and we're at -1. Now we're going to go into the fourth quadrant. Again, sine is still negative, but it's starting to come back to 0. And this has created a graph of sine. We know that this will keep repeating, okay? So our curve will just keep repeating and repeating every 360 degrees. We can also go back to negative angles. Imagine if I dragged it back, it'll just do the same thing in reverse. So you can see in the first graph there, we've got a graph of sine x, and we can see it starts at 0, it goes up to 1, back to 0 at 180, down to -1, back to 0 at 360, and then it just keeps repeating forwards and backwards. Okay, a cyclic graph. Let's have a look at cos theta. So recall that cos is actually the x value. So when we have an angle of 0, the cos value is actually 1. Okay, and as we start to increase our angles, so now we'll go along a little bit, 3 degrees, we can see our x value starts to get smaller, okay, just the pink line, and we're graphing it up here. And we'll keep going. It's getting smaller and smaller till eventually when we hit 90 degrees, our cos, our x value, is 0. And now it starts to go into the negatives. And all the way to 180, where we hit -1. As we go into the third quadrant from 180 to 270, it's still negative, but it starts to approach back down to 0. So when we hit cos of 270, we get back to the 0, okay? 0 on the x-axis, remember. And finally, we'll go into 270 to 360. Our cos value, the pink line, starts to increase until it gets back to 1. So over here on the graph, we've got our angles and our x values. So at 90 degrees, the x value is 0. At 180 degrees, the x value, or cos, is at -1, etc. And of course, that can repeat just like sine did. And so our second graph here shows us what the cosine curve looks like. You can see similarities. It's the same shape. It's just shifted 90 degrees in the, what's that way, horizontal direction. Okay, so how can we draw our reciprocal graphs while we're here? Okay, so first of all, we know that if we want to draw cosec, it's 1 on sine. So the first thing I realised is sine could never be 0 for cosec to exist. So where sine is 0, we're going to have asymptotes for cosec. So dot those into your graph. when sine is 1, cosec will also be 1. So sine is 1 here, so cosec will be 1. Sine is negative 1 here, so cosec will be 1 on negative 1 or negative 1. Okay, cosec, negative 1 here, positive 1 here. We also know, let's just focus on this first part here, as sine gets really small, 1 over sine, 1 over a really small number, will actually be really large. Okay, do that on your calculator. 1,000. So when sine is small, cosec is really large. When sine is small, cosec is really large. And we create our shape. This will repeat in each branch. Okay, let's have a look at sec. We know sec is 1 on cos. So same sort of scenario. When cos is 0, we're going to have an issue. We're going to have an asymptote because we can't have 1 on 0. So we drop our asymptotes in first. When cos is 1, sec will also be 1. When it's negative 1, 1 on negative 1, negative 1. So we'll drop those in. Run out a bit of room, so I'll just do these ones. Now again, we have the same shape because as cos gets really small, sec gets really large negative, okay? Forget about the bad terminology there, but you know what I mean. As it approaches 0, it approaches negative infinity is what I should have said. Then we have our graph of y equals sec x. Okay, so let's have a look at an example which I've used solving technology. On the same set of axes, we have y equals sine x and cot x. We haven't had a look at him yet, but we'll come back to that. So reciprocal tan, not quite as fun as sine and cos. Use graphing techniques or otherwise to find when sine equals cos. This is just their point of intersection. So it's here, 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 and here. And we're going to have to estimate that. So to me, that looks at about 310 degrees. I don't know, it looks a little bit over 50, not quite 60. Okay, so that's probably a little bit out as well. And we're just looking from 0 to 360, which is about up here. So don't worry about this part of the graph. Okay, they're not looking at those. So we'll estimate that x is about, what do you think, 52 degrees? Or there'll be a second solution at about 300, I don't know, a bit rough there. I think it's a little bit shorter. So let's say 308 degrees. You must estimate until we start to try and solve these sort of equations. And you will be using graphic technology and not expected really to do that by hand in test conditions. So on the next page, we have a summary of our graphs. We've looked at sine, we've looked at cosine, tan. Recall that tan is actually sine on cos. And so what I'm doing is I'm dividing each point in sine by cos. So when sine is 0, tan will also be 0. Okay, so these points here will replicate. And I'll just focus more on 0 to 360 to start with. Now, when cos is 0, we're going to have an error. We're going to have an asymptote. So at 90 degrees, we've got an asymptote here. At 270 degrees, we've got another asymptote. And what's that? An extra 30, 90, add 90. 450, we've got another asymptote. Now, what you'll start to realise is sine 45 and cos 45 give the same value. And we recall that tan 45 is 1. Obviously, 1 on root 2, which is sine 45, and 1 on root 2 would actually be 1 whole. Okay? And as tan starts to approach 90, start putting values, tan 89, tan 89.99. You'll see it starts to approach infinity. Okay? Start putting in values closer to negative 90, and you'll see that also starts to approach negative infinity. This will then repeat. Okay, so 180 degrees later, we've got our next repetition there. 180 to get to that dot, and we've got our next repetition, and so on. We've looked at cosec, we've looked at sec. There's some nice, neat versions for you. Cot, if you recall, is 1 on 10. So when 10 is 0, we're going to have a problem. So we've got problems here. We've got problems at 180. We've got problems at 360. We could also do it by looking at cos on sine, but I find this a bit easier. And what you will notice, tan 45 is 1, cot 45 is also 1. When tan is an asymptote, when this approaches infinity, cot will actually be at 0. Okay, so the asymptotes for tan are the zeros for cot. Quite often I just do a quick little table of values to help me and get those key points, and then I'll know my shape. It's the reverse direction of tan, you will notice. Okay, because if you take this little piece, say here, 90 to 180, 90 to 180, shouldn't have chosen negative, but we'll go for it. As tan approaches 0 from the negative side, cot will approach infinity in the negative side. Similarly, if I look at this bit here, as tan approaches 0 from the positive side, cot will approach infinity. And as tan approaches infinity, positive, cot will go to 0. Okay, and again, we've got our replication. So if we work at 90, we can add 180 to get the next dot, etc.